Um, Now I'm going to run through the tutorials one by one and instruct you how to get the Ansys software as well. So before doing anything, before going into the tutorials, you need the software and Ansys software for you. So Ansys software is available in this website. Look at this one, and you can download Ansys from here, Ansys student. So if you go there, you have now you can see this download Ansys student 19.2. Actually, I have used Ansys 19.1 because 19.2 was not available, but visually there is no difference between the two software. So first thing that you have to do is to download Ansys 19.2 from the Ansys website as given in here, and install it in a computer that uses Windows, and then you can use this software to do the tutorials. The first tutorial tells you how to generate a mesh. You know why you need a mesh. A mesh is needed to represent the fluid that you are going to simulate. Fluid. Now, in this tutorial, what you are doing is creating a mesh to do a pipe flow problem. So in these tutorials they give you step-by-step instructions on how to run the software. So for example, if you look at this tutorial introduction and getting started, that's the fourth line of this one, and you are asked to go to the start menu, all programs, Ansys 19.1, workbench 19.1. So if I do that in my computer, what I do is I go to the start button, I go to Ansys 19.1 and I click that one. Then I have workbench 19.1 here, so I click on that. Then you will get the software appearing in your computer. And then you run through the tutorial, run through the instructions. You use the workbench. Workbench is actually the platform for running Ansys software, because there are few pieces of software that are embedded in the Ansys suite. In the first tutorial, what you're supposed to do, as I explained earlier, is to create a mesh. So this instructs you how to start Ansys and start a project. So Ansys comprises of a few bits. One is the geometry. Then you need to create a mesh. Then you need to set up your simulation. Then once you have set up the simulation, you set up the solution, and then you do the setup, and then you run the simulation, and then you have a solution. Then from the solution you create results, you create plots. So those are the 5 elements in here. And then it's a matter of running these sequentially, to set up a geometry, set up a mesh, then to do a do the actual setup, and then run this and get a simulation solution, and then looking at the results. So in the first tutorial, what you're supposed to do is just to follow the instructions one by one. Once you have created the once you have installed the software, you follow instructions from one by one to create the geometry. So with this, briefly, I'll tell you what you're supposed to do here again. So there is a CAD package in the software. So it is called Design Modeler. So you can open Design Modeler and then you draw the geometry. So to create the geometry, you can use the standard shapes. We for the pipe flow problem, what we are using is a cylinder. Then you give the dimensions of the cylinder, the radius, and the length of the cylinder. Mind you, the radius here is actually 0.05 meters, not 0.5 meters, and the length is 0.8 meters. And once you have created the cylinder, you go to the you can then create a mesh. You can view what is in there, and then you can create a mesh. So when you create a mesh, you can ask the software to automatically create a mesh. So this is what you have done here, and then you go into more details later. So what you can do is you could obtain a refined mesh depending on the physics problem that you have, because for a pipe flow problem like this, you know that you need to have a refined mesh, or mesh that can solve the wall functions. Therefore, you need a higher grid resolution near the wall, and not that high grid resolution in the center. And if you ask the software to do a mesh itself, it will normally create tets or tetrahedrons, but what you may want are hexahedrons. So therefore, what you do is you use what you call you give it inflation, and you give a smooth transition in that inflation. So once you have done that, you can create a mesh like this. So follow the instructions step by step. So you will end up with a mesh like this for your pipe flow problem. And then the next thing that you do is you need to set the boundaries. So mind you, this is your inlet, this is your outlet. You can see the X, Y, Z coordinates here. So the actual axial direction in this coordinate system is Z, not X or Y. And then you use the select tool to select faces. So that is the outlet. There you have the inlet and then the wall. So what you do is give names. So you give the names using the function create named selection. So once you have done that, you can save your project, and if you go back to your Ansys window, you will see that your setup is done. Tutorial 2 defines a Lamina pipe flow problem better. Here what you do is what is given is the geometry of the pipe. You can see that your length is 0.8 meters and your diameter is 0.1 meter, and coefficient of viscosity mu is given, as well as the rho is given as 1 . row is given as 1, and the tasks that you have to